Hello, and welcome to another episode of the Women in AI Research podcast. I'm Ekaterina, and I'm joined by my co-host Malika. And today we are excited to welcome Wanru Zhao to the podcast. Wanru is a PhD student in computer science at the University of Cambridge in the UK, where she is supervised by Professor Nick Lane at the Cambridge Machine Learning Systems Lab. She's also a part of the Cambridge AI Safety Lab that is focusing on AI alignment and interpretability. And currently she's visiting the Vector Institute in Toronto and collaborating with the Professor Colin Raffel at the University of Toronto. Her research targets the development of more decentralized AI by focusing on AI methods that are less centralized and more collaborative. So, Wanru, welcome to our podcast. We are very excited to have you here. And to start with, can you tell us a little bit about what first sparked your interest in artificial intelligence? Maybe there was some specific moment or some specific project that lit that spark.
Yeah. Thanks for your question. I'm truly honored to be here. Actually, after getting the invitation, I listened to our previous episode of this podcast, and I was really inspired by the incredible guests you've had. So I feel very lucky to join this lineup. So for my first spark, my interest, I would say is during my high school. I participated in the programming context. We call it Olympiad in Informatics in my high school, where I got touched with the coding and algorithms. One time after the competition, there was a lecture given by previous participants of the context. It's about Monte Carlo tree search and A-star algorithm. And at that moment, exactly at that year, AlphaGo came out. So I watched the whole game of AlphaGo at that moment. So at that moment, I was really inspired by the AI and machine learning algorithms. So after entering college, I started to explore AI research.
That's exciting. So AlphaGo was your spark, right?
Yeah, exactly.
Great story.
Sounds great. So can you walk us through your journey to pursuing a PhD at Cambridge? Were there any mentors, experiences, or turning points that shaped your decision to go into academic research in particular?
Sure. My journey to Cambridge actually started during my MPhil there. So MPhil is the Master of Philosophy in UK education system. And so I finished the MPhil in Advanced Computer Science program, which is a kind of research-based master program where I was first introduced to some more rigorous academic research training. And we had several coursework where we call it modules that were very hands-on, and our professors gave us detailed feedback. And I think that shaped how I think about such research and my career plan. And at that time, my master project was part of the open source framework of Flower, which is a federated learning framework. And I was very excited about this direction at that moment. So I decided to continue to my PhD after graduating from my master program.
That's amazing. Have you thought about doing research while entering the MPhil program as well? I'm just wondering, there is a slight difference between MPhil and the MSc, right? A Master of Science. Was it in the back of your mind already in the beginning of the Masters that maybe you will want to go to research?
Yeah, you mean my understanding or my experience showing the differences between the MPhil program and MSc program. So as far as I know, for MSc program, students are required to take a lot of courses, which are very helpful for finding a good job in industry as a software engineer or research engineer. But for MPhil projects, and also combine the atmosphere at Cambridge I feel like it's more academic driven, and it's more theoretical. For like the coursework, what we need to do is to finish the tiny paper, and most of them are like the independent work, and we need to we are asked to go through the whole process of like coming up the idea and design the experiments, and then the write-up phase.
Yeah, sounds interesting. Some of our audience, some of people from the audience will be interested in those different options as well, and we'll explore them more.
I would say that like my experience during my master's was pretty good. So I strongly encourage people to apply for this program. Yeah, I really like it.
Great. Yeah, thanks. So right now you moved to Canada during your PhD, right? And you work at the Vector Institute. And I know that you have also interned at Microsoft and also at AWS AI Lab, right? So you have a lot of that very, I would say, diverse experience of working in different research ecosystems, like UK versus Canada, industry versus academia, research in both of those areas. I wonder, how did that influence your perspective as a scientist?
Yeah, I feel like the differences among those places are quite striking and enriching. And in UK, especially in like more academic parts of it, research is more independent, and people often take a very long-term view, not necessarily chasing the trends. And there's a strong focus on theoretical depths and curiosity-driven work. And it's a slower pace. That's really a really valuable kind of training. And in Canada, what I feel is that, particularly at Vector, I felt much more collaborative and aligned with what's happening in the broader field. And there's a stronger emphasis on conceptual innovation, I would say, and building like maybe shared language across like slightly different subfields of AI. And I really enjoyed that environment. And I found that many research directions at Vectors, they are connected with each other in surprising ways. And as for in industry, actually my internships were all in research, very research focused teams. So it's all about like it's almost similar to doing research in school or like in universities. And my mentors could often like identify the core issue with just one or two comments, which was incredibly satisfying to me. Yeah, and I think that there's also more access to resources. So
In the
if you already
industry.
have a concrete idea and want to try that aligns with the whole team's focus, the pace will be faster.
Yeah, so it sounds to me that, like, from what you have said, from your experience, it's maybe even possible that there was more difference for you between UK and Canada rather than research in the industry and research in academia.
So I think that for the like personal experience, it's based on the specific team or supervisors or people you are working with. So I think it's all like it's largely dependent. It's largely depend on the specific team or so I don't think like one cannot do theoretical research in Canada or cannot do like more empirical research in UK. And in both of the countries, I observe like the same passion for research, for conducting good research. So which make me like really encouraged.
Cool.
Nice.
Speaking of the differences between industry versus academia. So right now you told there's more access to resources there, but this is my long-term goal so that we break this wall between industry and academia and like both communities have equal access to resource. And yeah, like in your opinion, how can we make these two ecosystems more collaborative so that the students, the smart students, have more access to the resources, and industry also benefits from the deep research outcome, theoretical one that can be applied into their work and maybe be profitable for them at some point. So how do you think these two ecosystems can be more collaborative, and we, maybe the ones who are working in the field, can help to actually fade away that drawn border between them?
So the question is about like the collaboration potential, like building potential collaboration between the academia and the industry. Yeah, that's a pretty good question. So I feel like some of the research topics, they are naturally suitable to be applied in the industry like environment, while some like the others, some of the topics, they are like almost purely curiosity driven. So I think it will be definitely perfect to build such collaboration between industry and academia, especially for those like very empirical research, because industrial, like there are more computing resources in industry and it can be closely connected with certain products in industry. But for like some of the research directions, I feel like it's more long-term research line that we cannot see. We haven't seen many like direct applications of those research topics. And I do see some of the industrial research labs working on those stuff. For example, like DeepMind, and used to be working on like DeepMind is working on some like traditional RL algorithm, and also there's some like very close collaboration between DeepMind and UCL Gatsby Center, which is working on the neuroscience part. And for like the AlphaGo I mentioned, and also some like AlphaZero, they are all based on such research. So those kind of research directions might not be the mainstream at some moment, but it will be beneficial in the long run.
Cool. Yeah, it was very interesting. Thank you for your response. It was very interesting. So in all those moments, either in industry or in academia and like, I don't know, in different countries. So over all these years that you were doing research, have you ever felt like you're completely lost, maybe academically or personally, and you needed some guidance to see what the next steps are or how you can replan your roadmap? Were there any lost moments there?
Yeah. There were one kind of the lost moments. Is about feeling alone or feeling lonely, especially when I was working on things that didn't attract much attention, and it made me question whether my research matters. And also another another kind of like lost moment is I feel like it's from the uncertainty of the research itself, because you cannot control all of the things. The experiments could fail, and also you cannot control like the if people really cares about your research topic. And that, like, I feel like it's a constant unpredictability, and it could be very like emotionally draining. Yeah.
It resonates very strongly with me as well, because I can very well understand how both those points, like whether the research is failing and you do not control it to the point, to the level where you feel confident about what you're doing, and also you're not sure as a scientist, as a researcher, whether what you're doing is actually having any value for other people. So I wonder how you usually deal with those moments, or maybe not even moments necessarily. How do you deal with them?
Yeah, I often remind myself that passion can withstand the test of time. And also, I think finding like-minded people makes a huge difference. Knowing that someone else shares your values and vision makes you feel less alone. And on a practical level, I try to follow very structured methods or steps that give me a regular feedback, so I can see my progress more clearly and stay grounded. And also having a constant daily routine and a supportive system around me is also very important, including friends and advisors, collaborators, families, or communities. I I feel like I got much help from communities like Women in ML, and also there's a club in my department at Cambridge called Women at CL. CL means computer science, computer laboratory,
Mhm.
and that helps a lot too.
That's great. That's great. I hope that even sharing those experiences may help some other people. So thank you for doing that.
Yeah.
Yeah, great. Thanks for sharing your experiences. So, following what you shared, have you ever felt like an outsider in your field, especially due to your gender? If so, how did you deal with that? Yeah.
Yeah, absolutely. I think one example would be doing such kind of feeling came from a very young age. Like for example, during my high school, as I mentioned, I was part of the Olympiad informatics teams in my high school, where I was one of the very few girls in my high school participating in such context, in such competition. And at that moment, I feel like I'm an outsider because the majority of the participants are boys. So at that moment, I was trying to behave like others. For example, like to show I'm a very competitive person. I'm a very aggressive person. So called such traits. But later on, like when I got to know more like girls or ladies in that field, I felt more at home. So finding like similar people, I think helped me a lot. I don't need to be someone that's not like that's not me at all, and we can share our like ideas or thoughts or feelings with each other. I think that's a very good experience. And yeah, and I also believe that like that's why I really like our podcast. And I think this is a very good platform that we can share some like personal experience that may be very commonly seen in others' lives. Yeah, and even if we cannot find someone that has experienced similar things before, um, like I would tell myself if I can, like manage to do this, then maybe others will come after me and will feel a little less alone when they see someone like them in this space.
Amazing. I love those words. It resonates so well with me as well. Wanru, let me ask this question, and it will be the last out of research question. So there are multiple so-called unspoken rules in the research culture, right, in academia. So if you were in the position that you could break one of these unspoken rules, which one would it be and why?
Yeah, that's a great question. So I think one of the like unspoken rules in academia is that seems like only positive or novel results deserve to see the light of day. So in that case, if we have some negative or failed experiments, like we cannot even write them up at all. So if I could break the rule, it could be the culture of burying negative results and actually sharing such like intermediate experimental results where some initial exploration does matter. And I've seen similar patterns in some very like frontier research lab in China. In China, like the size of the labs is really big, and one advantage is that people are working on similar stuff. So they can share internally which error they encountered and also share the failure examples. And those failure examples are very important for conducting research, even if we cannot include it in the paper.
I love it. It reminds me, there was one workshop, I think, sufficiently recently, maybe several years ago, started at one of the NLP conferences, which was called exactly like that, negative results, something in the research. So yeah, I completely agree. There should be more places to share to publicly those negative results, because these are still results. We need them as well to make progress, not just like the cherry-picked best possible ones.
Yeah, I totally agree.
Yeah,
Thank you.
great. I also really love that answer. So I think people talk very little about their failure points on social media. And also, it's not only about research. I think that's something we see. We just see half of the actual research world there. And I think, especially speaking of Gen AI, it's a very expensive industry. And sharing those failure examples would save a lot of time and cost for everyone in the field, but there's no stage for that, no venue in particular to share. So I hope people change the directions a bit. So yeah, that was great. Thanks for sharing your personal journey. Very insightful. I personally learned a lot. So let's now dive into your research. To start us off, could you break down what the scaling laws are in the context of language models, especially for those who may not be familiar with this?
Mm-hmm. Yeah, so scaling losses are the majority of the the majority of recent works in large language models, they follow such scaling laws that intuitively means that if we put more compute into it, more data set into it, we can get better performance of the models.
Right. So from your perspective, are there the limitations that we face today as researchers when we try to scale models further? And if so, what are those limitations, the way you see them?
So when we are talking about the scaling law and thinking about the conventional deep learning model deployment, we are talking about essentially three elements, which are data, model, and compute. And we usually assume that these three things are located in the same place. So nowadays, we're starting to run into some serious resource bottlenecks that could prevent us from scaling the models much further. So from the perspective of the data, so training large language models need numerous text data set. And there have been some prediction that we could run out a publicly available data set on the internet by around 2026 if we keep scaling normally. So in other words, just grabbing more web text won't be enough. So we need new ways to access or generate training data. So this is one part. And the other part is a compute. So the standard approach is to use bigger and bigger GPU clusters with high-speed interconnects. But building such ultra-large data centers is incredibly expensive and impractical, because not everyone has such a sparse multi-exaflop supercomputer. So according to this, I'm wondering if we could instead scale out training across many modest models, for example, GPUs in the wild, connected by the normal internet. So essentially, it's turned the internet into training clusters. And that would let us use existing compute spread across the globe rather than concentrating everything in one location.
That's great. And I love how you pointed out that these scaling limitations, bottlenecks, they're not just, let's say, compute or just data or just model. They're coming from all three different places and probably should be addressed also in different ways.
Yeah, that was very insightful. There were a lot of news headlines in late 2024 that AI scaling is hitting a wall. And I saw a very nice blog post a couple of months ago, and it was saying that there is a bit of misunderstanding or misconception about what scaling laws mean. The reality is that all these scaling laws are exponential, like kind of functions, but everywhere, especially like in all the relevant papers, we just see linear charts. And that's why the expectation of people in the field is that if you linearly pour more data or more compute or linearly increase the size of the model, you should see a big jump in the performance. But actually, the actual relation between the performance and all these factors is exponential. So to get to the next jump into the field, we need to pour a lot more data and compute in it. So yeah. So speaking of the data part. So in general, you advocate for open and collaborative large model development, an innovative and timely strategy. I'm eager to explore how your research engages with all these different pillars of data, model, and compute. So in your New Reefs paper, which was called Clues, Collaborative Private Domain High Quality Data Selection for LLMs via Dynamics, you talk about data attribution, essentially measuring how much a training example influences a model's predictions. So what are the main challenges of applying existing attribution methods to LLMs, especially in collaborative or federated?
Yeah, so previous data selection where data attribution works lie in the centralized setting. But as I just mentioned, like, we need to consider about such collaborative setting. And in such collaborative settings, different models may be trained on different sources of data, which means that different data attribution. And how can we select those data that is beneficial for the global model instead of the local model independently? I think this is a critical question, and this is what we want to address in this paper.
Right. So, what are your thoughts and how do you want to address this? How do you want to identify that high quality data from distributed sources? Some of them are privately held sources and they have all those different characteristics.
Yeah, so in that paper, we come up with a method that calculates the data scoring function on the user side based on the checkpoint during the training. And once we got the per sample scores, we send it to the server and we have the global standard, which is a global score threshold that could help us to filter out those data that we want to in the collaborative training. So with that global standard, we can filter out those data which is lower than the standard and keep those data which is higher than the standard. And in that case, like for the global, like the collaborative learning, we did experiments on both of the settings, which are model merging and federated learning. And we showed that in both of the settings, our method can achieve the best performance.
And you mentioned that global standard or global threshold. Where does that come from?
So the global here, our assumption is that we have very small amount of data, which is public data, and it is recognized as the high quality data, and we can always, like, everyone can access to it. For example, the Wikipedia data, and we use those data as our anchor data to calculate such threshold. So that's what we did in this paper. We are working on the follow-up paper, which we don't want to make such threshold a fixed value. We want to adaptively adjust it, and it's coming out soon.
That's nice. Yeah, that's very interesting. I'm looking forward to that new paper of yours. Would it be fair to say, with regards to that global threshold, would it be fair to say that it is coming from the domain knowledge? Like it can be domain specific or something about that?
Yeah. So, when it comes to the collaborative learning, because people train their own model on their own devices with their own source of data, that make it possible to apply it to some like very sensitive domains, for example, like healthcare domains or financial domains. Yeah, I think that would be a very promising direction to apply our method.
Interesting. So once you've selected high quality data, how do you perform collaborative learning, especially under low bandwidth or low communication constraints that are very common in real world federated setups?
Yeah, actually, this is sort of out of the scope of this paper because we just use the normal federated learning setting and the model merging setting. We didn't change anything. Yeah, so because in this paper we are focusing on like more data centric methods.
I see.
I see. So maybe some follow-up in the next works if it is of interest.
Yeah, it can be compatible with some like different variants of federated learning paradigm or model training techniques.
Mhm. Yeah, makes sense. Yeah, and you have mentioned in this paper that you also used model merging in your training phase. So could you tell a little bit about this model merging and how that enables collaborative fine-tuning of LLMs, especially when dealing with sensitive or private data that cannot be shared?
Yeah, sure. Actually, I'm really passionate about model merging and such like modularity architectures. And we have held a workshop on modularity in collaborative, decentralized, and continuous training in 𝐼CLR this year in Singapore. And so for model merging, like before mentioning model merging, there's a concept called task vector. So this is a task vector is essentially a representation of a specific task's knowledge, and it is often encoded as a set of parameter updates or differences in the neural network. And so model merging basically combines multiple task vectors or models together by averaging or interpolating their parameters to create a single model that can perform multiple tasks effectively. So basically how it relates to modular architecture that so it is also closely connected with what I mentioned as a collaborative training paradigm. So if we can make the model in the modular and pluggable architecture, that would be very easy for people to achieve such collaborative development of it.
Cool. So you also ran different experiments across domains like medicine, finance. What were the key takeaways? In what ways did clues outperform existing data selection methods?
Yeah, actually, yeah. So this is the general method, and it's not specializing such domains, but it can be applicable to such domain.
Mhm.
But maybe I can talk about a little bit about the big picture behind my paper. So when I was thinking about, like, when I was coming up with this idea, I'm thinking about building such a continuous integration or continuous development component to the, for example, the GitHub or the GitHub of the model version. For example, we have Hugging Face that people can share their checkpoints of the model, and in such of the community or platform, we wanted to use clues as a CI or CD component, which means that every user can commit their own model or adapters to the server or platform. But we cannot guarantee whether or not their models are trained on some bad data or poisoning data. So this is one issue. And the other issue that if we want to develop the global model, for example, via model merging, we don't know if like such two checkpoints have conflict or interference between each other. So if we can introduce such CI/CD components, for example, clues, we can do such fine-grained kind of unit test. And so those of the models that pass the test can be committed to the platform. Otherwise, we will report the evaluation result or the unit test result to the user, and user can adapt or update their model checkpoint a bit so that it can be successfully committed to the platform.
I see. That's interesting. And thanks for that high level motivation for the work. It makes it more clear to me of how you combine that data attribution method with the model merging and how it all goes into one place. Can you give me a little bit of intuition? How do you see the potential applications of this?
So the potential applications, as I just mentioned, as the big picture, I've already seen some trends or works recently working on such building such a platform or interactive environment. And I'm really excited about that. And I think this kind of work can be very promising to be part of it.
Mm-hmm. Yeah, that makes sense. So if to think about the future research in collaborative LLM development and data quality control in situations like that you are describing, what is still missing, you think? What could be those blind spots that are currently under research and need more exploration?
Yeah, that's a good question. From my point of view, I think another very important component or other important kind of relevant direction is a mechanism design to incentivize people to contribute their own models or adapters. So essentially, because such data from personal sources are very important to train the model, but it cannot be directly collected. It can those kind of data have its own value. And if we can find a good way to incentivize people to contribute their models, not directly their data, because when people train their own model, it's a combination of the data and the compute. So if we can find a way to give the users the composition of their data and compute, which are their models that they contribute to the environment or community, that would be very helpful. And I have some ongoing work in this line, and hopefully it can be released soon.
Right. Are you open to speaking a little bit more about that ongoing work?
Yeah, so our initial attempt in this line is that we wanted to see in which case we can incentivize people to collaborate with each other. For example, when we already mentioned several collaborative training paradigm, including model merging, and also there's a other training paradigm where other collaborative paradigm, and mixture of expert could be one of that, and also the model merging, which makes that each of the adapters are trained independently, and then we have a router to combine all of them. So those are different kind of collaborative development ways. And how can we select which subset can be formed as a collaborative collation that could lead to larger benefit or larger revenue. In that case, how can we incentivize each of the the model provider so that it could get benefit from joining certain collation? So that's what I'm currently working on.
Interesting. So, turning to the model pillar, I would love to delve into your 𝐼𝐶LR paper, Breaking Physical and Linguistic Borders, Multilingual Federated Prompt Tuning for Low Resource Languages. So, what are the primary linguistic and infrastructural challenges you've observed in multilingual fine tuning of LLMs, especially when working across diverse geographical locations or language families?
Yeah, sure. As large language model develops, we found that not all languages have been treated equally by developers and researchers. And we found that there are around 7,000 languages spoken in the world, and approximately 400 languages have more than 1 million speakers. So it's very long-tailed distribution. But there's a scarce coverage of a multilingual dataset. So this is especially true for low resource languages where data scarcity is a major bottleneck. And also the certain languages, some certain languages, we don't have access to such data sets as well as the compute resources. For example, the mobile data, the compute and other computational resources may often be very expensive or unavailable in the regions that are home to such underrepresented languages. So unless we address this kind of representation, we will risk perturbating this divide and further widening the gap in language access to new technologies. And one example I can come up with is one example I'm thinking about is about medical data. So due to its global scale, this digital content is accessible in a variety of languages. But most existing NLP tools remain English-centric. So this kind of situation highlights the need for such effective strategies about how we can exploit such abundant labeled data, how can we exploit such data from research. It's about how can we exploit such data from resource-rich languages to make predictions in research low languages.
Yeah, and so your method leverages that federated learning, right, in multilingual settings. And can you tell us a little bit more about that? Because the motivation that you outlined seems to be really important. It's a really important problem that's worth solving. So what's your approach to solving that?
So the approach here is actually it's very straightforward and it can be quite similar to what federated learning is doing. So basically we train the model, we do the parameter efficient training on the user side with their own compute and their own language dataset. So we can get such prompt encoder. If we use prompt tuning, we can get such prompt encoder trained in different languages. And then we do the parameter aggregation of such prompt encoder to make sure that, we get a global prompt encoder that extracts the common languages pattern. So in that case, we can benefit the low resource languages from the common languages pattern.
Cool. And you highlight that your approach offers better generalization and stability, especially for low resource languages that are linguistically distant from the pre-training corpus. I'm curious, how do you define language distance in this context? What impact does it have on model performance?
Yeah, that's a good question. We define a pre-trained language as a representative language formed by mixing each languages in the multilingual corpus used for pre-training. So we define the distance for a specific language in the downstream tasks in terms of the sign similarity to the pre-trained language. So here, if a language distance is really high, means that it tends to be the low source language.
Right, and the main language that you compare to is English, right?
The main language we are compared to. So we have calculated the composition of the pre-trained languages. For example, in Llama 3, in Llama 2 we used, we have such, because Llama 2 is trained on multilingual corpus, but it's not well trained on the low resource languages. So that's why we calculated the distance between the pre-trained corpus and also our downstream corpus, because our downstream task may include some low resource languages. And in our experiments, we use different kind of languages, including some African languages and also some other low resource languages.
Right. That makes sense. There is quite a lot of research nowadays, I guess, in multilinguality, right? And can you speak a little bit more about how you see the future directions of this method, of this work, and where do you see it can go further in the next?
Yeah, thanks for your question. As I can see it, based on my current development, my current method for multilingual fine-tuning, way that we can do is to sort of client selection in the federated learning field, but I would say it's a clustering of some similar languages so that we can make sure that the prompt encoder that we trained is similar to others so that it can benefit with those like languages that are similar to our downstream languages. So this is one direction that we're exploring. Also, recently I've seen many like progress happening in the coherence model called Aya, and this is what I like. I'm following Cohere's work for a long time, and I've seen a very large community working on such multilingual data set and benchmark on Aya, and I feel really excited about that.
Right. If to speak about Cohere's work on multilinguality, I would also mention several multilingual benchmarks that were out late last year and this year as well. I'm mentioning them is also because I was involved in some of them, and it's Include and the Kaleidoscope. Those are the multilingual benchmarks for multiple choice questions, and we also have a lot of different languages there. So something else just for the context.
Wow, fantastic.
Cool. Thank you, Wanru. So, what do you see as the key challenges and opportunities for scaling this paradigm to support a wider array of languages, regions, and device types, given your research in the field?
The key challenge might be the efficiency, because if we want to do such like collaborative learning paradigm, we need to first train on we need to finish the training, and we need to get the model or adapters, and hopefully we could achieve such training on personal devices. Once we can achieve that, I think there's a broader future of such collaborative training. So in that case, we need to find a good way to do such training on the user side.
We spoke a lot about multilingual models and benchmarks. I wonder, can you tell us about maybe some follow-up work that you are interested in right now, currently, that you are working on, that is somehow related to the topic?
Sure. I have a recent work just released on arXiv. It's about Cascade inference. It's called Cascadia. So this is a joint work with other fantastic collaborators. And so the idea here is, so the motivation here is like the smaller, we all know that apart from large language models, there are more and more smaller models that are getting stronger. For example, like Quinn model families, there are super fantastic smaller models. And so this kind of the smaller model can achieve good results and less latency. But running those models on when we are considering running the models on resource constrained devices or environments, there are several challenges or factors we need to consider, which is we need to balance the latency, quality, and limited compute resources. And this work is about addressing this by leveraging test-side compute and cascade inference. So the cascade inference is essentially about the mixture of or combination of large language models and small language models together. So the idea is very simple, which is to use small, fast models for easy queries and only use bigger, slower models for hard ones.
That's interesting. When you say small and bigger, what does it mean? How big should be small, and how small should be small, and how big should be the big models?
So in our experiment, we use a smaller model, for example, the DeepSeek 7B as a small model, Llama 3AB as a small model, and for the larger model, we use a DeepSeek 671B model. We also tried some medium-sized model, for example, the DeepSeek and Llama 3B. So different size of the models.
Interesting. Yeah, people have different definitions of what SLMs are versus LLMs. I think for industry leaders, 70 billion parameter models is still an SLM, but in academia, when you have limited research, 14B is also LLMs. Yeah, interesting. Thank you. Yeah, as one of our last questions, what's your top piece of advice for young researchers entering the AI and ML space today?
Yeah, so I would encourage people to talk to more people in this field and also seek for guidance or mentorship for those people who are senior, more senior than them. And it's always good to collaborate or learn to collaborate with each other, because at that moment, it's very hard for people to achieve very good, very impactful to do very impactful work independently. So collaboration is always a key. And yeah, and I also feel that when I was very several years ago, I was afraid of seeking advice from senior people. But later on, I found that as like I am a mentor, I mentor students sometimes at the moment, and I can get a sense of satisfaction and achievement from mentoring younger people. So yeah, so don't hesitate to seek advice, build collaboration with others.
Exactly.
I love that. Also, it reminds me how you explained the differences that you have experienced between the UK's research ecosystem, where people are more independent, and Canada's slightly more collaborative vibe. So I'm glad that you're sharing that encouragement to collaborate that maybe came from Canada.
Cool. Yeah.
Yeah. And also for as for my PhD group, I'm really, really lucky to be in a group that was a very good collaboration atmosphere. So yeah, I feel like I learned a lot from collaborating with other people.
Yeah, exactly. Teamwork is the key. So thank you, Wanru. I really enjoyed our conversations and learned a lot. I'm a big fan of decentralized training and federated learning. So thank you for joining us today. So for listeners who want to learn more or follow your work, where can they find you or stay updated on your research?
Feel free to reach out me via X or Blue Sky, where you can also find me on my personal website.
Great. Thanks, Wanru, for joining us today. And for those of you who'd like to dive deeper into Wanru's research or connect with her, we will add links to her publications and socials in the podcast notes. Be sure to check them out. And we are going to be back in 3 weeks with another episode spotlighting the brilliant minds reshaping the future of AI. See you in 3 weeks.